All right, good morning. So today we're going to talk about solving inequalities with one variable. Solving inequalities is almost identical to solving linear equations. We're going to use a lot of the same techniques by moving variables around back and forth and also moving our constants around back and forth, but we only have one different exception. So let's kick it off with, we have two equations or inequalities on the board right now. You notice one is a positive out in front and one is negative out in front. We do something different when we have a negative, when we do a certain operation with a negative number. But we'll get to that in a second. But let's just do the first one. You're going to see that this is very similar to solving linear equations. So I'm going to act like this greater than sign right here is just an equal sign. That way it doesn't throw anything else off. So I'm going to take away 1 from both sides. Because I want to isolate out my x. So I want to get rid of the 1 and eventually the 3. I'll drop down my 3x. Those cancel out. And I got 21 over here. So I got 3x is now greater than 21. All right? Like I said, nothing different from linear equations. Now I want to divide both sides by 3 because I want to get that x all by itself. All right, so if I divide both sides by 3, now I get x is greater than 7. So that's my answer. But in a lot of cases, we also want to graph it. And in graphing an inequality, we mainly put it on a number line, especially with simple inequalities like this. How I usually graph it is I take the number, I put it in the middle of my number line. I just do a couple different points on both sides. So this will be a 6, that will be a 5, that would be an 8, and a 9. We're going to put a circle on the 7, because 7 is the star of the show. And this says x is anything that is greater than 7. So we're going to go in this direction and shade the rest of the number line in that direction. There we go. So any one of these numbers are possible answers to plug back into the original inequality. Like if I plug 9 back in here, 3 times 9 is 27. All right, plus 1 is 28. Is 28 still greater than 22? Absolutely. I can't plug these numbers in because then it would make it a false statement. Like if I plug 5 in, 3 times 5 is 15, plus 1 is only 16, and we know 16 is not greater than 22, so it wouldn't work. All right, let's move over here. Here's where there's a subtle change, but an important one. So we're going to start off by solving it the same way. Let's get rid of the 1 first. All right, cancel that out. I get negative 3x greater than 21. All right, so far so good, no changes yet. However, now instead of dividing by a positive, I'm going to divide by a negative. Now I get x. Now, here's where the change takes place. Whenever you multiply or divide by a negative, when you're doing an inequality, what happens is that inequality sign flips around or changes directions. So since we divided both sides by a negative 3, this inequality sign is going to go from a greater than sign, all right, to a less than sign. Basically, it was looking like this, and we switched it around. Now it's going to look like that, all right? It's like that little dance move. All right, so now I get 21 divided by negative 3. That gives me a negative 7. All right, so that's the answer. And if we're asked to graph it, which you will be in my class for the first few inequalities, I'll put negative 7 in the middle now. There's negative 6, negative 5, negative 8, negative 9. Once again, we'll put a circle around negative 7 because that's the one we're talking about here. That's the star of the show. And x is anything less than negative 7. Now remember, even though these are negative numbers on a number line, anything to the left on a number line is going to be negative or less than. So we're going to kind of shade in this direction. Now here's the cool thing. It helps you out with what direction you're going to shade in, especially when you're doing simple inequalities. If you have the variable out in front and the number second, this little arrow here kind of shows you which direction you're supposed to shade it when you're doing simple inequalities. That's only when you have the variable out in front. Notice over here, the arrow kind of points to the right, so we shade it to the right. So that kind of little helpful hint that might help you out in your graphing in class. All right. Now, what happens if the variable ends up on the other side? All right, we can easily just flip it around. So this is a quick little simple equation. If I divide both sides by -4 to get the x all by itself, all right, that would cancel out. I get -4. Now remember, I divided by a negative. That means the sign has to turn around. And I only have an x over there. All right, so that's the answer. Now, is that a correct answer? Absolutely it is. However, sometimes most things are listed with a variable first. So if you're ever asked to switch this around and put your variable first, here's the easiest way to do it. Put your variable on the left, the actual number on the right. Now, remember back in elementary school when you learned inequalities and a lot of your math teachers told you like an alligator, and the alligator likes to eat the thing that's greater than. So what you're going to do here is look to see what the arrow is pointing at. The arrow has to point at the same thing down below. So since the arrow is pointing at the -4, it has to still point at the -4. All right, we didn't switch it around at all. We just kind of wrote it backwards. So notice this is very similar to the top because the wide mouth is still facing the variable and the arrow is still pointing to the number. All right, so if you do switch it around like this, you just got to kind of change your inequality sign again. And this will actually help you graphing because now if we have to graph this, we're going to shade to the right. If you try to graph that, you might get a little confused with it. All right, so let's do one with a couple different steps. Actually, if you want to try this, pause the video, try this, and then unpause it and see if you got it right. Hold on, I'll wait. Okay, we're back. So -3, what we're going to do is distribute. Just like linear equations, we're going to try to clean up both sides, see what we can do. Whenever we notice we have parentheses, we always should think we can distribute. We can multiply whatever's on the outside times both terms on the inside. So -3 times 2x would be a -6x. And -3 times a +2 is a -6. We still have our less than sign and 10. Now what's the next step? We're going to add 6 to both sides. We're going to get rid of this 6 before we get rid of the 6 that's the coefficient for the variable. So let's add 6 to both sides because remember, whatever we do to one side, we have to do to the other. Even though it's not an equation, we still got to kind of keep it balanced. We can't unbalance it and change the inequality or change the equation at all. All right, cancel that out. I get -6x is less than 16. All right, so that's less than 16. I'm going to divide both sides by -6. So I get x not equals x. I remember, since we divided by a negative, I got to flip the sign around. It's going to be greater than, and this is going to be, we're going to reduce this down. Let's write it out as it is right now. It's -16 over 6. But we can reduce this fraction down. Let's change it to x is greater than. The easiest way to do this is if they're both even numbers, try to take half of both. You got to see what number can go evenly into both numbers. The highest number that can go evenly into both numbers is a 2. So we'll change this to -8 over 3. And there's our answer. All right? Simple enough. All right, so the next one. All right, so this one, if you notice, the inequality sign actually has a little line under it. So there's a slight change when we graph that as well. All right, so what we're going to do is we're going to see what we can do to the left side. Look, I can distribute it. Okay, because I got parentheses, so I can distribute this. I can't do anything to the right side, so let's distribute first. So I get -4 times 3 is -12x. -4 times a -1 is a +4. I haven't done any, I can't do anything with the 6x, so I'm going to drop it down. And now that's called greater than or equals to 16. All right, now, what can we do on the left side now? That's right, we can combine like terms. I had two different terms that actually have a variable attached to them, and it's the same variable. So I can combine them. So negative 12x plus 6 gives me a negative 6x. Because negative 12 plus 6 is negative 6. Now it's plus 4 is greater than or equal to 16. All right? Now we're back on track. So now we want to subtract 4 from both sides to get rid of the 4. Oops. That will cancel. I got to drop down my negative 6x because I haven't done anything with that yet. It's greater than or equal to 12. All right, so now we got to divide both sides by a negative 6. That cancels out. Now remember, we divided by negative. That means we got to flip the sign around again. So this is going to be x is now less than or equal to negative 2. Oops. And there is our answer. Now, notice it's less than or equal to. Now, here's where we're going to grab it slightly different. All right, so what I'm going to do here for the graph, let's put it up here. Let's do a number line. The number we're discussing is negative 2. We'll put that somewhere in the middle. We'll put a couple of points on both sides. Like I said, usually I do 2 on either side. All right, now, because it has a line underneath, this is where we don't do an open circle, we do a closed circle. All right, so we're going to put a circle around there and shade it in. All right, because now what this means is negative 2 could be a possible answer. All right, if there wasn't a line under here, it means x is anything less than negative 2, but negative 2 is not the answer, but anything less than it. But since there's a line underneath, it means you include negative 2 as well. All right, so like a little chart. Oh, by the way, let's finish this out. So x is less than or equal to negative 2. Let's shade this side in, as less than is always to the left. Now, just kind of like a little chart for your notes. If you don't have the line underneath, that's an open circle. Closed circle. Is when you do have a line underneath. Okay? So line, closed circle, no line, open circle. All right, now we have 2 special cases with this. We're going to get kind of some tricky answers here. Very similar to linear equations. All right, so let's solve this. All right, so let's look at the left. What can I do on the left? Well, I have parentheses, so I can distribute. Multiply the negative 3 times both terms on the inside. That's going to give me negative 6x. Negative 3 times negative 5 is a plus 15. Is greater than negative 6x plus 9. I can't do anything with the right side, but I was able to fix the left side up a little bit. All right, so now we're going to move all the variables to one side, all the numbers to the other side. It doesn't matter which side you move them to. I personally like to move my variables to the left because I like my variable out in front. All right, so if I want to get rid of the variable over here and move it over to this side, the opposite of subtracting 6x would be to add 6x. I'm going to add 6x to both sides. Wait, that cancels that out. And this is going to cancel this out too. So all we're left with is 15 is greater than 9. All right, we don't have a variable anymore. Is this true? Yes. 15 is definitely greater than 9. So this is true. So this is where we have infinite solutions. Very similar to linear equalities. I'm sorry, linear equations. Oops. Screen's moving a little bit. All right, but what this means is any number I plug in, because it has to be the same number because the variable is on the same side. Whatever number I choose, when I plug it in for x over here, plug it in for x over here, it will not change this. It will always be true. So this is true because any number we plug in, because that is a true statement. All right, let's fix this one over here. All right, so now I can't do anything with the left, but I can fix the right. All right, so I can distribute because I have a parentheses. 2 times 2 is 4, oops, 4x. Get rid of that little dot. And 2 times negative 3 is negative 6. All right, so once again, I want to move my variables to one side. I'm going to subtract 4x here. I'm going to subtract 4x over here. They cancel out, and they cancel out. Okay, well, let's see what we have left. I have a negative 5 is less than negative 6. Is that a true statement? It's not a true statement because negative 5 is greater than negative 6. Remember, on a number line, negative 6 is farther to the left, so it's less than negative 5. So this is a false statement. So this will be a no solutions. That means nothing you plug in, it has to be the same number for either side, is ever going to make that true. All right, if you have any questions, please ask me in class. If you're not in my class or you're in a former class and watching this or a future class, leave a comment or question down below. I will check my comments and try to answer it for you. All right, take care, you guys. Have a good day.